Today we are going to learn about volumes of prisms and cylinders. In general, when we talk about the volume of these prisms and cylinders, no matter what the shape is, we are going to find the area of the base and multiply it by how tall the prism is. Same thing with the cylinder. And then the cylinder's like the same thing. It's like a prism, but the only difference is it's going to have a circular base. So here are our postulates that we are going to cover in this lesson. The volume of a cube postulate. The volume of a cube is the cube of the length of its sides. Because remember, in a cube, all sides are the same. So really, you're just multiplying or cubing the side length. So side to the third power. The volume congruence postulate states if two polyhedra are congruent, then they have the same volume. And then the volume addition postulate is the volume of the solids is the sum of the volumes of all of its non-overlapping parts. So basically what we're going to do is just chop up the figure and then add up all the different sections of our figure to get its volume. We're going to apply the volume addition postulate, postulate number 29. So the volume of a prism is where B is the area of the base and H is the height. So notice in my formula, this capital B, this isn't like a base length like in a triangle. This is actually the area of the entire base. So whatever shape is on the base, we're going to find the area of that figure, of that polygon, and then multiply it by how tall the prism is. So don't get confused with a lowercase b and an uppercase b. So notice in this figure, the area or the shape on the base is a rectangle. So we would find the area of the rectangle and then multiply it by how tall the prism is. Generally, when you see volume of this, maybe back in middle school, they teach it to you as length times width times height. Because length times width would be the area of the rectangle, and then times how tall it is. You might also see it as base times height, but these two heights will be different. Slide. Again, cylinder. So just like a prism, it's going to be like a prism, but with a circular base. So a right cylinder is segments joining the centers of the circular base, and that would be your altitude, which is also known as the height of the cylinder. So the altitude of the cylinder is also the height of the cylinder. Yes?
So if it's a right cylinder, that's when you can find the volume, but if it's not a right cylinder, you can't find the volume?
No, we can. We're going to see some oblique coming up cylinders where it looks like it's slanted. But what will happen is the height won't be a right angle. It's going to be outside to show how tall it is. To find volume of any figure, we need to know the height. So in this particular right cylinder, the height is inside the cylinder, and it's going to connect the centers of the two circular bases. So the height's going to go from top to bottom, from the centers, when it's a right cylinder. But if it's oblique, the height will be outside, and we're going to see that in a minute. Slide or numbers aren't important. So here is the formula for volume of a cylinder. So the volume of a cylinder, again, capital B, which is the area of the bottom times the height. Notice the shape on the bottom is a circle. Notice in my formula here, pi r squared, that's the formula for area of a circle. So when it's a cylinder, the shape on the bottom will be a circle. You will find the area of that circle, pi r squared, and then multiply it by the height. So here we would need the radius and then the height of the cylinder. Here on the first to us, we're gonna actually try this one. Okay, now notice they're walking you through. Remember the formula for volume on the previous slide was capital B times H. Now, the capital B represents the area of the base, which in this case, when it's a right cylinder, is a circle. So pi r squared is the capital B part times how tall my cylinder is. So the height of my cylinder here is going to be 7, and my radius is 5. So to find the area of the bottom, I'm going to do pi r squared, so pi times 5 squared, or 25 pi. If I multiply that, 25 times pi, if I use 314 for pi, and I multiply it by 25, I get 78.5. And these are centimeters squared right now, but when it turns into volume, my units are going to be cubed. So again, for volume, it's BH, and again, it's pi r squared times height. I've already done the area of the base, which was 78.5, or 25 pi. And now I'm going to multiply it by the height, which is 7. So if I'm leaving it in terms of pi, how much money is 7 quarters? Or what's 25 times 7? 175 pi, right? And then centimeters to the third power. If you're going to go ahead and multiply out the 78.5 times 7, then multiplied out is 549.5 centimeters cubed. Here, where we're going to apply that, we're going to sort of think of this as like a complex figure. And I can sort of divide this into two smaller figures. So I could put a dividing line right here, and I can find how many cubes are in this top little cube here, and it's got a volume of 1, which is 1 times 1 times 1. And then I could find the volume of the smaller rectangle, or not, the larger one of the two, and I could multiply 3 times 2 times 1, or 1 times 2, and this is going to be 6 cubic units. And then I would add up each thing, and 6 plus 1 would give me 7 cubic units. Or actually, no, it's not cubes. It's not centimeters, it's cubic. Let me erase that. So you could either spell out, you could put units to the third, or you could write cubic units. Either way. So you're going to find the area of the base times it how tall it is of each one of the rectangles here. And the top one is actually a cube, and the bottom one is a rectangular prism. So this would have 7 cubic units. Wants us to find the volume of a square prism that has a base edge of 5 and a height of 12. So if I draw a square, draw this in a different color. So I've got my square base here. Let's see. Let's sort of make this really tall. I don't know. I can't draw 3D. Let me redo this. And actually it needs to be a square. Square bottom. And let's make it really tall. Here's my square prism that has a height of 12. So again, the formula for volume is capital B times H. So I'm going to find the area of the bottom, which is 5 times 5, or 5 squared, times how tall it is. So 5 times 5 times 12 is 300 feet cubed. Volume is always to the third power, the units. So that would be the volume of my square prism that has a height of 12. Next slide. Now we're going to do the volume of a right cylinder. So I'm going to draw 2 circles here. Maybe I should not. Let's make it a little bit neater. Make my cylinder here. It says it's a right cylinder and it's got a height of 18 inches, but they've already given me the volume calculated. So again, I'm going to plug it into the formula. So volume for a right cylinder is pi r squared times height. So I know that my volume is 684 pi is equal to pi r squared, and I knew my height because it's 18. So now I have to sort of work backwards. So I'm actually going to divide this by 18 pi to get r by itself. So that cancels away. Also, the pi's cancel out. And then 684 divided by 18 is 38. And that's now equal to r squared. And then to undo the square, I'm going to square root. So my radius is equal to the square root of 38. And you can leave it like that. If you actually did it on your calculator, the radius, and if we round it, say, to the tenths place, we end up getting 6.1644. Rounded to the tenths place would be 6.2. And these were in inches, so 30 square root of 38 inches or 6.2 inches. Either way. This is the oblique prism. So whenever it's an oblique prism, that means it's sort of like slanted, and we can't really find the height inside the prism. So the height is usually going to be indicated outside, and it's going to be a number that's next to a right angle, because the altitude is always going to be a perpendicular distance. So for this one, it's still the same thing. We're going to find the area of the base, which is a triangle. So base times height times half, or base times height, divide by 2, times how tall the prism is. So remember again, formula for volume of a prism is capital B times the height. Again, capital B is the area of the base. And in this particular question, my base is a triangle. And the formula for area of a triangle is 1/2 BH, or BH divided by 2. So for here, my base is going to be 9 times 5, and I like to divide by 2. So 45 over 2 is the area of my base, or my capital B. And then multiply that by the height, which is 8. I'm going to simplify this and make this 4. And now 45 times 4 is 180 meters cubed. So that would be the volume of this oblique prism. And that's it. Now, when you're doing the homework, everybody good on this slide? You will have to go back and use the formula for area of a hexagon or an octagon. I believe they give you everything you need. They give you the ANS. So you're not going to have to turn it into a right triangle or anything in the practice A homework. So let's go ahead and take a look at it. Your homework tonight again is practice A. We'll take a peek at it and see, and I'll just give you a quick overview of what you're expected to do.